Welcome back to Code with Me 4. This is all about functions. So previously we learned to store values and variables, and then we slowly progressed into working with collections, so different things like lists, sets, dictionaries, tuples, and then from there we've ran multiple lines of code. But how do we actually keep things clean, reusable, and easy to manage? So that's where functions come in. These are going to be the step-by-step code or ideas or algorithm that we write. But this time, instead of just writing it in like a blob of code, what we're going to do is just place them into a repeatable block of code, break them down into more smaller manageable programs. And this is like building a car piece by piece. So this is where you're going to get to know how to actually group your function or group your ideas together. In doing that, the process that we're actually going to be using is called hierarchical decomposition. And this just means dividing a big problem into smaller, focused pieces. So, for example, here when we actually create our main function, it is going to be, consider it like our control center. It's just going to drive the program by calling each of the other minor functions that we will create from task one all the way down. And this will allow for us to have that one main function be the only thing that runs when this file is executed directly. And we're also going to use something below hand when we get to it, which is also a built-in feature within Python here. So the first thing we're actually going to do by structuring this function is to define our main function here. So how we go about creating a function is we're going to be using a keyword called def. And this def keyword allows us to identify that this is going to be a function here. So after we have used def keyword to actually say we want to define a function, everything else after that def is going to be the setup that the function needs, which is the function name, the inputs, and any instructions later. So we want to think of this as like giving a label to a new machine that you're building before it does anything. You have to define what it is. So in this case, we're just going to use def. And then we're going to have our function name called main here. And then inside of this function main, you can name it anything you want. And the naming conventions for functions will be letters, and you must start with at least a letter or an underscore. And it can include numbers, but no spaces or special characters. And it just should describe the function itself. So in this case, we're just going to say this is a main controller function, so that's the function name. Right after the function name, what you'll notice is that I also have open close parentheses here. This is going to hold our parameters, the input the function can receive. So you can leave it empty, or you can add variables inside of it, which we'll see later on. The very next part of this function header here is going to be the colon. And this colon just tells Python that a new indented block of code is about to start. So everything indented below is belonging to that specific function. So again, any function needs to have your function name. It needs to have the parameter. It needs to also have the defined word, the function name, the parameter, and the colon, as well as any function body with the indented code block inside of it. So in this case here, we did good. We have our function header here. All right, so the next thing that this function is going to actually include is it's going to include all of our function calls. So in this case here, I'm just going to put a little document info at the very top to let me know that this is going to be my main controller function here. And I'm also just going to put here that this is code with me 04 here, all functions. And then for right now, because the part that we could use here will come in a later task, I'm just going to go ahead and do a quick print statement and just say in main, just to make sure that it's tested out and works. So now we have a quick function here, and usually what we would just do is this would be a comment and then this would be our print statement, but you'll notice the difference in when you guys are creating your block of code prior to creating function. You would just be able to print here, and we could say in something to print, and then this would be what we ran to execute it. The difference here is inside of a main function, we have everything tabbed over or indented over, which is a tab, I believe, gives you 4 extra spaces. So in this function, how we can actually run it, because if we tried right now, after I save it, to run this block of code, it'll run, but there's nothing that's going to be outputted. And that's because we have to do something that is called a function call. We need to say, okay, we've already defined the function, but now we actually want to use a function. So let's go ahead and call this function. And so in order to do that, we can simply just do a main call here, and this will call this function. And typically use this whenever you want to test out a function just to make sure it works little by little. And it's going to take its time. So we see now that it does print in the main, and so we know that this function call works. But there is also another section that we're actually going to be looking at that can also do function calls a bit as well. All right, so in this section, I'm just going to go ahead and add this in. So this next section, we're going to be using a statement that is called, it's called a few different names depending on like where you look at it and all that information. So some of the most official terms would be calling it like a main guard or even just an entry point or a main conditional statement here. So in that case, what it would actually look like is we first start with using an if section here, and that if part is going to first check to see if it's true or not. So we've seen this portion before. We've seen if, where it's a conditional statement. The word if tells Python, check this condition. If it's true, run the code underneath. So here, Python is just checking, that if section. But now we want to add onto this statement here a name. And so here we have name underscore underscore, and both sides you have 2 underscores in the front, 2 underscores in the back. And this is a special built-in variable. So every Python file automatically gets a hidden variable called underscore underscore name underscore underscore. That's double underscore at the beginning and double underscore after the name. And so the value of name is going to depend on how the file is actually being used. So for example, here, which is what we'll use, we're going to be using this file, and it's going to run directly by clicking on the run button. And that means that here we're just going to have main underscore underscore. This file is the main program, so this is what I want to run. And we need to make sure that it has equivalent symbol. So we're saying if underscore underscore name underscore underscore, that special built-in variable is equivalent to main, then this file is the main program that we're going to be running. There's also one that is the file being imported into another file, which is just going to be the file name, and that's going to be used as a module by importing it. And you'll see that in a moment. But for right now, this statement here is our entry point statement. It's saying, am I the main program that's being run right now? And in this case, yes, it is. So we're going to make sure that we tab that in. Now, in the past, or at least while we were coding through, you saw me putting in function calls and other functions. That's perfectly fine as well. But I do want to introduce this entry point statement so that you kind of know what it's being used for as we progress later on in the semester. All right. So another aspect of this that we're going to get right into is if we run, for example, this specific script as a file later on when we get into Python files, you'll see that this will actually run and execute the main function, which is great. That's what we would want. Now go ahead and save this, and I'm going to run it so you can see it does the exact same thing the other function does, or the other way of calling the function does. So it still prints out where in main, and I'm going to go ahead and put in main 2 so that you can actually see the difference there. It's not old output, it's the same output, it's just being updated. So now that we have that main there, the nice part of this that I want to show you is just how we can actually use this file to run line by line in another file. So this, what we're going to do here is just create a separate file, and I'm going to just call this file a simple math tool. So I'm going to first save this. Oops, that's not what I want. First save this, open up a little bit more, and add to this folder here, MOA. And I'm going to move this up a bit, just add a file. And in order to create a file here, and I'm just showing it to you through Visual Studio Code, I'm just going to click on that new file button. And then here I'm just going to click on this file, and I'm just going to say, I'm going to name this file simple math .py. So we're using .py this time. So in this case here, it generates a new function, a new file for me called simplemath.py. And in this, I'm just going to go ahead and define a function here. I'm going to define at least 2. I'm going to have add, and we're going to take in 2 parameters. Don't worry, we'll get into this in a moment. I'm just going to return a plus b here. And see this here in a moment. All right, and then I'm also going to define another main function here. And I'm just going to have a print statement here saying running math, or running simple math.py. And then I'm just going to do a quick print statement calling my add, and I'm just going to do 5, 5. So we're going to get 10 hopefully printed back to us. And after I call that function here, again, you don't need to do this. I'm just showing you an example here. We're going to do 5 plus 5 here. And I'm just going to do a simple save. And then I'm going to make sure that I have that entry point there. So I'm going to have if space underscore underscore name underscore underscore is equivalent, so 2 equal symbols, quotes main, and then quote underscore underscore main underscore underscore, and then a colon. And then inside of here, I'm just going to call our main function inside of this class. I'm going to save this real quickly. And before I actually go about doing this and using this, let's say I genuinely just want to create another file, and I'm going to just use this function here that we have here. So this is just going to be the welcome to Code With Me for file. So I'm just going to create another one in this function to show the difference. Here, I'm just going to say code with me 04.py. Enter this, and then I'm just going to paste this function in this file here. So from the get-go, we have this function, and what I'm going to do just to showcase that we have been in here is I'm going to just assign this to a variable called message. And then I'm going to actually, instead of printing out in main, I'm just going to print out message. And that way we know that we're inside of this specific Py file. This is specifically to demonstrate what the process of using this entry point can look like if you were to use this. So let's say I want to import this specific file here. What I'm going to do in my simple math.py file, I'm just going to go to the very top and I'm going to do import. And then I'm going to import code with me 04. And then what I will do inside of this main function here is I'm just going to do code with me 04 dot, and you'll notice the only thing we have access to is that main method inside of code with me 4. So I'm going to click on that. And in this, I'm just going to have open close parentheses here. So we see that here we are accessing the file code with me 04 and the main function. So now when I run this file here, we should see running simple math pi 5 plus 5, and then at the very end here, what I'm going to do is just have a separate print statement, and I'm just going to say code with me 04 dot main here as a string to showcase that's what I'm looking at. And I'm going to do a \n here just to give it a new line. And then what I'm going to do is run this function or run this file. So we're going to do down arrow and do run Python file. And then you'll see here in the terminal, we have the output running simple math file. We also have 5 plus 5, and I probably should put equal there to make it more readable, but it's 10. And then we have the call code with me 4 dot main to this. And we see that it does print now welcome to CWM for all functions, and that's just specifically from our Python file here. So in the future, if you're wanting to completely make your own modules, you absolutely can in this way, and it works well by using the entry point here as well. Thank you. So we're going to move on from this simple example. We're going to move on from the example that we have here, where we're looking at your main function, to now going into task 1 here, which is just printing out function type here. So in the next step here, when we're actually looking at we're going to create a function called dynamic typing demo. And this one isn't going to take in any parameters. We're going to create one variable, assign an integer to it, print out that value and the type, and then we will reassign to a string and then to a list and print out each type. Whoops, actually I skipped task 1, which is 6.2. I think, yes. All right. So we have already created a function that we have a main call, and we've kind of gone through that part. Now let's focus on 6.2 rather. So in this first one here, we want to define a function. So we know we got to define the function like so with a capital D or a lowercase def here. And we're going to make that example called, or that function called, print underscore examples. And this one doesn't take any parameters. So we don't have to worry about passing in any values in here, and that'll make sense here in a moment. But the first thing we want to do, what it says to do, is print out three strings separated by commas. So first things first, if you don't know necessarily how to do this process yet, what you would just go ahead and do is probably potentially have a variable here. We can call it, we have a string called Liddell. And then let's say in the next thing where we want to print out, we can just have three separate sections where we're going to just print it out. So here we're just going to do print. We'll print out name, then we'll print out a fruit here. We have a banana, and then here we'll print out age, and we'll put, I don't know, anything over 21 there. And those are all three strings. So you can choose to assign it to a variable or make the actual string a literal value, passing it in, but they're all separated by commas. This is important to know as you are learning code, that whatever instructions are given, you want to make sure that you follow that to be able to follow the client rules and also whatever your teacher is asking you for. So in this case, we know we have three strings. They are separated by commas, so we can move on to number 2. Now we want to have 3 strings and 1 integer. So in this case here, I already have a string called name. And since, again, we're needing to reuse these strings again, I'm going to have another string here. And I'll just say, we'll make it first name. So we'll have first name, we'll do FN. And then we'll have one that's called last name. And I'll just put decoff here. And then we have fruits already. Oops, get rid of this F name. All right. And so the next thing we're going to actually have here is the actual the number value. So I'm just going to put age 21. We'll go ahead and put that as an integer value there. So we're going to go ahead and do our next print. So we need to have our 3 strings. I'm going to have my first name, last name, and then we're going to just place in their literal value. We'll have a colon here just to have a separation. So we have another string. And then here, what we'll do is we'll put in our age as an integer. So we're going to put that variable there. So now we have number 2, where we have 3 strings and an integer. The very next thing we want to do is we're going to print an F string showing some sort of math calculation. So we're going to do print. And then in here, we're going to use the F string. And so outside of the first quote here, we're going to have our F. And what I like to do is I like to first start with the placeholder. So I'm just going to do equal, and then I'm going to do 5 plus 3 as the example just to make sure. But then on the string side of it, I'm just going to show 5 plus 3, and we should say equals 8. And then we should check here, 5 plus 3. And then here I'm going to just place backslash n afterwards. Okay, and so here we have our 3 items that we are going to print out. Now, before we move on to checking to see if it works and then testing it out, we want to make sure we copy the function header, and we're going to make sure that we call the function. Here we're going to just test it out in this cell, and we're going to call it underneath. It should be aligned underneath, not indented in. So I'm going to go ahead and save that, and we're just going to run this function to check to make sure it follows the rules. So we have 3 different strings, good. Then we have 3 strings as well and an integer. And then we have our calculations, and it does have both 8 for that. So we know that this works. So now that we've tested it out, we can comment this section out and use that function header to call it directly in main here. Oops. And one thing that I do want to indicate to you, usually this if statement here, this check entry point, will be at the very bottom of your source code. So in this case, I'm just going to copy this and move this all the way down to the very bottom. And I'm going to just put code here. And before that, though, I will just go ahead and place this here and just make a comment saying using entry point. And if you wanted to, you can use markdown at the top to just kind of have a header. And for this one, we could just say this statement here. We'll run it. And then let's run it at the top of that. Okay, so we know that works. Let's clear all output, and then just run. Gotta save it. It's just taking a while. Okay, it looks like it works now. So here we have our if main, and actually we can just make that 3 and just have another thing here just called using. And then now we're going to clear all output and run all again. All right. And so now we have this section and we know that this main works. All right. So we can move on to task 2. So the first task was fairly easy. We know that function has defined keyword, doesn't have any parameters, and we tested it out. It worked. The next thing we're going to do is a little bit of review, but also still adding on to the knowledge we have. So in the past, you guys used the type built-in function to check out the different types of your variables. And so here you're just going to be redoing the same process, as well as your list object type as well. The only difference is you're just going to be defining your function. So pause the video and try your hand at doing task 2 before you actually see it. All right, so here we're going to actually get started into doing task 2. So first we're going to define the function dynamic underscore typing underscore demo, open close parentheses, colon. This isn't going to take in any parameters. So the next thing we're going to do is actually read the next line, create one variable. All right, so I'm just going to create a variable value. And we're going to assign to it an integer, and we're going to print out that value. So just going to assign the integer 21. Then we're going to print out the value and the type. So if we get to print out both, what I'm going to do is just say value, colon, and we're going to separate that by comma, then value, then comma, we're going to put a pipe symbol to separate the two. Then comma, I'm going to put type here, and actually this could be one string, so we can do type here, colon, comma. And then on this other side here, we're just going to use the type built-in function, and you'll notice it highlights and turns this kind of blue. And so we just going to pass in an object here, and in this case, we're going to pass in value, and we'll be able, we will be able to see, okay, yeah, we'll be able to see the type value there. So at this point, we can, if you guys are trying to review and understand, we'll probably hope that this type will check, does it return int, check that. And then the next thing we're going to do is assign to it a string. So we're going to use the same variable called value. And then this time I'm just going to assign to it 21 as a string. And this time I'm going to just use the same print statement because we're reusing the same variable. So it would only make sense to do that. And this one should turn out to be a string if everything was printed out correctly. Then the very next thing we're going to do is have value. And this one, we are actually going to assign to it our list object. So in this case, we know that to create a list, we want to use an open close square brackets. And in the parameter or in the actual list, we're going to just put in some fake values. So I'm going to do 2.3, comma, 4, and then even strings, we're going to put in Helen in there, a name, and even a character as well. So we have a list of values. Let's see. Yeah, then we have a list of values. And so in this case here, when we display this out, we should also see a value of this list in particular. So we should see that it's a type list. So now the next step of this is for us to test our code out. So what we're going to do is copy that function header there, and we're going to call this function and just to make sure that it works. So when we run it, we see, yes, we have our type integer, type string, and then type list. And so we know that this function works. We know that we've tested it out, and we know that we have everything that the instruction is requiring us to have. So in that case, we're going to copy that function header, and we're going to call our function below. Here. All right. And we're going to save it and make a run just to check to see everything fits out good. All right. So we have all three of those set there, so we can move on to the next section. So the next section is going to be, I believe it's 6.5 here. This is task 3. So 6.5 is going to be seeing us build and write our mathematical function. And this is just going through the worst to the easiest, or the easiest to the hardest portion of coding here. So you'll notice that the Zybook relation is a little off, but the actual task is numbered correctly. So in this case here, what it wants us to do is define a function called built-in functions. It doesn't take in any parameters. We want to create a list object list object called numbers, and that's going to take in 4 values, 5, 3, 8, and 1. We're going to print out the length of that list, the maximum value in the list, the minimum value in the list, the sorted list, the abstract value of 10, and we're also negative 10, and then also rounding 3.567 to the nearest 2 places. So in this case here, this is just going to give us a little quick performance on analytics before getting deeper into processing data. So in this case here, we're going to define this function called built-in functions, open close parentheses, and then we're going to create that list called numbers. This is going to have 5, 3, 8, and 1. Then the next step of this that we're going to do is, first things first, let's get the length. So we know we have to print that out. So I'm going to go ahead and print out this. I'm just going to make sure we get a header in there. Built-in functions. I'm going to do /n so that we know where we are, and I'm just going to label this as task 3. All right, and then what I'm going to do is print out the length of this. So we're just going to go and print, have our length built-in function here, and we're going to pass in as a parameter to this built-in length function our list called numbers. And this will return the length to us. We could also assign this value to a variable called length. And then we could also print that out. And both of those would be applicable. So you could use either or, and it would work. The next thing that we are actually going to be looking at, instead of just length, is we're going to be looking at max and minimum. All right, and so in this case here, I'm just going to have a variable that I call X here, and I'm just going to type in max and pass in the numbers list as a parameter into that function, and it should get stored into this variable max. And then I'm going to do the same thing with min. So we have min, then I'm going to store or call my min function and pass in numbers here. And then next thing I'm going to do is I'm going to make sure that I print those two out, and I'm going to use fstring for this. Maximum value in a list, open, close, and then we're going to have \n, and then we're going to have minimum value in a list, open, close, curly braces, and \n. And then what I'm going to actually have here is just going to put numbers, and then I'm going to put the list here, which is 5, 3, 8, 1, so that at least we have something to look at with that. And then a little bit of this, space, a little bit of this, space. And then now I'm going to put in my variable max as the first parameter for that placeholder. And then I'm also going to put in min here as my second, is my second parameter here. Okay. Now that I have this minimum portion here, the next thing I'm going to actually do is do the sorted one. So we're going to just do sorted. So we're just going to do a print statement here. And I'm going to go ahead and make sure that I store this in a variable. I'm going to just say sorted list equals. And what I'm going to do is just call this sorted function with my numbers list. And I'm just going to assign the return value to sorted list here. And then I'm going to make sure that I print that out. And I'm going to, again, use fstring. So I'm going to have numbers. We're going to have that 5, 3, 8, 1. And I'm going to make sure I put my /n. I'm just going to put original numbers first, and then afterwards here, I'm just going to put sorted numbers. And then on this end here, I'm just going to put the sorted list variable as a placeholder. So we should be able to see that then. Okay. I'm going to make sure that this is also new lined here. All right. So the very last part of this that we're going to be looking at is using the absolute function and the round function here, and then we're going to check it and test it out. So we're going to use absolute and also the last one, round. All right. So in this case here, I'm going to just have a variable call absolute value equals, and we're just going to put abs and put -10 there. So we're going to store that value into that variable, and then we're also going to do rounded value, and I'm just going to store inside of round. The value we're looking at is 3.567, so 3.567, comma. And in this comma here, you'll notice the default is there's no digits that you need to round to. In this case here, we can actually give the number that we would like it to round to. Otherwise, it will return the same type as the number. And so in this case here, I'm going to say that I want it to actually be rounded to 2. And that's what the instructions say. So in the next step here, I'm just going to print it out using fstring. And then here, what I'm going to just have inside of here is just say the absolute value is, and we're just going to have abs here with the -10 to show what it is. And then we're going to have absolute value variable in there. And then the next thing we're going to have here is have our /n, and we would say the rounded value of, and we'll just do round 3.567, comma 2 to give that second round space. Then we're going to have our open, close, curly braces, and just put the variable here, rounded value. All right. So, and I'm going to make sure that I design it in the same way so that at least we can see it proper. So we're going to go ahead and do the same thing here. All right. So now we have all of the things that this task is asking us to do. We're going to want to now test it out real fast. So I'm going to copy this function header here, and I'm going to place it down below and make sure I am in the right place. So here I'm going to just do testing, paste it, and we're going to save it and then run to make sure it works. So we have built-in function. I should probably make sure that I place their length of list. And I'm going to go ahead and just put this, save, and run it again. All right. And we'll just make this space as well, save, and rerun. So it's all the same. All right, so we have a length of list, we have 4. Then we have the maximum value 8, which is true. The minimum value 1, which is true. Then we have, does this list look sorted to you? It does. So it was in 5381, now it's 1358. And then now we have the absolute value of 10 and also this value 3.567 rounded to 2 decimal places. So we see that this works, this function works, and we kind of have our experience with data analytics aspect of it. So we're just going to copy that header, comment out the testing portion. We're going to scroll down to the main class here, and we're going to call it down here. All right, and so the next thing we're going to do is save and move on to task number 4. And so with this task, it requires us to define calculate area, passing in a variable, but we're going to leave the body empty with pass, and we're going to use the docstring. And for this one in particularly, I want you guys to try your hand first at defining the function header with passing in the radius, and then pause the video, and I will actually move on to the next step here. All All right, so we are actually going through and defining this function. So I'm going to go ahead and do that right now. We're going to define it and call calculate underscore area, and we're going to pass into the parameter some radius, but in this case, we're just going to type in the variable name radius. We have our colon, and then it says leave the body empty. And we're going to also add a docstring in there as well. So in this case here, I'm just going to place inside of here some docstring. And in this case, I'm just going to say quick thing called stub, and then I'll explain what stub is. So this function will eventually calculate the circle's area later, though. So in this case here, we have this function, and then we need to also place in this body the keyword path. And one of the things that path is used for is it's a placeholder keyword in Python. It literally means do nothing yet. So when Python executed, it simply moves on without error. It often actually is used whenever you know what structure you want, like a function, loop, or a class, but you actually haven't written the code inside of it yet. So in this case here, we know that this is going to take in some radius and we have to calculate the area, but not yet. So in this case, we would actually like to use this if we know that we don't necessarily know what we want to place in there, but we know that we don't want to have some sort of error. You know, for example, if I were to call this function and didn't have path, we would have an error because there's nothing in there. So we will do this call here, paste, say, and run. And we get that expected, a syntax error because there's nothing in there. So pass is literally just used as a placeholder to say do nothing yet until we actually are ready to use this function. And oops, we don't want to have def there. So let me go ahead and show you that proper before. We'll move this be 10.5. Run it here. Oops, I gotta save it first. All right, and we know now that it's going to pass it. Needs to update again. Let's clear all output. Control save. And then run. Oh, you gotta put the comment because it shouldn't have anything in it yet. Okay. All right, so yes, this is what you would get, this indentation error, sorry, not syntax error. Before it was a syntax error because I just had def key there and not the colon. It's supposed to give that indentation error because there's no code inside of it. But once we add in our pass, we are able to pretty much skip through this function here, and it will pass over it. So no file can really run if it doesn't have anything inside of the body. So in this next section, though, when we use pass, what I want you to think of is just as a placeholder. So if, for example, there is a function or an application or program that you're asked to write, and it says define this function or define a list of these functions, you can go ahead and define them and put a docstring inside of it, meaning like this is just a document string indicating that there is some sort of this is the function that you're going to be using it for. This is how you're going to be using that function. And then afterwards, you can then implement your actual function later on. So it's a way for you to bypass those issues. So that's just what this specific task 4 was asking from us. And so now that we know that it works there at least, and here we have passed in a literal value of 10.5 that will actually get assigned to the variable radius here. And then that would get used in whatever calculations we use in calculate area. So we know that this works, our testing works. So we're going to comment this out and then call this function here in the main. Okay, paste it. Uses pass function. So that's just a note for you yourself to know that's what's being passed in there. So the next step for us is actually going to be working on task 6. All right, so the next part of this task, task 5, is for us to actually define a function called greet many names. And that's going to loop through a list and print out greetings from each name. So this is what we're going to be doing with 6.5, being able to have passing in some sort of list here, and we're going to be looping through that list and printing out greetings. And it looks like names is going to be what is the list's name, the name of that list object. And so the scenario for this is just being able to welcome each participant in the classroom or event. Now, in the past, for example, whenever we first learned variables, we knew for us to be able to assign a value, a string value to a variable, it would be, for example, here name, and I would put, for example, Liddell as my name, and that would be that variable. But let's say I wanted to add not just myself, but other names. I would then now, at that point when we first learned it, have to call this name 1. And then the next person I had be name 2 and assign that person a name. And then name 3 and assign that person a name. And so in that case, we've learned from just creating variables, it's really awesome to be able to store multiple people's names. However, what we're going to be paying attention to is actually being able to store these and now as a list. So we have a variable that is a list, and we're going to pass in there Liddell, we're going to pass in there Ben, and then we're going to pass in there Sophie. So we now have a list of names and that we will use for testing that stores in there all of the names that we would use. And we now know that we can use a for loop to iterate through those items. So we don't have to necessarily do name 1, name 2, name 3 anymore. So that is a great move that we've done. But what we want to do here is define this function called greet underscore many names. And then what we're going to have in here is our for loop that's going to iterate through that list. So we're going to say for every name inside of names, which is our list, now we want to print out a specific greeting for each person's name. So I'm going to go ahead and do print, and then I want to make sure that this is an F string. So I'm just going to say hello, and we're going to put open, close, curly braces as the placeholder, comma, welcome to our greeting function. And so now what we're going to do here is just place name. So we have a variable that can be used for multiple names that can iterate through that list there. So now we have that, and we're going to actually test out this function. I'm going to call it below here, and then we're going to test to see if it actually works. So we see, yes, it prints out hello Liddell, hello Ben, hello Sophie. So we see different names printed out for each person. And so now we see that this works, and it works great. So we're going to go ahead, comment this out, first copy it, and then comment it out. because we know that it works, save it, and scroll down all the way to our main function here. And then what we'll do is we have that there, and then we're going to have our function call there. And we're just going to test to make sure this works out perfectly fine. So there we do. We have all of the names there. And so we know that that works, and we're going to go ahead now. And we see that this one function is able to iterate through a list and display a good greeting. So this might be great for a project. If you have to greet a participant, you can actually store it in a list. And in the next task we're going to be going through, it's going to be task 6. So try your hand at it and then pause the video and play, and you'll see the rest. All right, so in this section here, we're going to go ahead and we have to define 2 separate functions, one called incorrect_add, and we're passing in 2 parameters, and we're going to print out the sum, but it doesn't return anything, and then we're going to have another one called correct_add, and it does return the sum, and we're just going to compare both behaviors. So in this case here, what we're actually going to be doing is first I'm going to just go ahead and define it, and I'm just going to define both of them. So I'm going to do incorrect_add, passing in A and B as a parameter, 2 different parameters here, and a colon. I'm just going to type in pass really quickly, and then I'm going to define correct_add, and we're going to pass in A and B as a parameter as well. And this one, we're just going to type in pass for right now, and that's just because we want to add in information. And here we're going to have our testing, and I'm just going to set it up. So we're going to call incorrect first, and we're going to test it with some values, and I'll just pass in here 4 plus 5. And then we're going to call correct down here as well, and I'm going to do the same where we pass in 4 to be assigned to A and 5 to be assigned to B. Now for the first one, we just want to be able to print out sum. So what we're going to do here is just have a print statement indented in here, and then we're just going to print out incorrect function with the sum of A plus B equaling, and we're going to have open, close parentheses there and just use F string. And we're just going to do A plus B here. All right, so that one we know is going to print it out. The next one we're going to do is actually going to be using something called the return statement. And this is just going to be used by using the return keyword here. And then on this side, we're just going to return A plus B, so the sum of A plus B. And so that means the fact that we are returning this value, it means that it's going to run this function when we call it, assign 4 to A, B, 5 to B, and then it's going to add that together and return some value. So it means that we want to be able to assign it to some variable here. And in this case, I'm just going to assign it to result. And then I'm going to print this out so we can actually see it, just to make sure that this function works. Now, in the first function call here, it's going to give us the same print statement. It's going to print out A plus P and then B, and then also whatever print statement we have in there, that's what's going to get displayed. The only thing that's going to change is the placeholder. And let me save here. And then here we see it says incorrect function sum A plus B equals 9, and so we do see that that prints out. But then when we call correct add and we do A plus B here and we return the sum here, it does print out the specific results that we have, and we can assign it to a variable. Now, some of the benefits of this is we have to understand here that this is the difference between just displaying information and returning information to be reused. So the benefit of the return function is it does return whatever you decide to return, and in this case it's going to be the sum, but it can be reused for later. So we have a variable that we can store it in, or we can just print it out directly. So when we call correct underscore add and pass in, let's say 5 plus 9 here, or 5 comma 9, and it will give us a different result. We can actually print that out or print out the results that we have and store it in a value. So the print, again, is just used for displaying information, and the return is just used for sending a value back to the program for future use. So the distinction, again, is the print doesn't actually save your value. It just prints out whatever you have. But the actual return, you can use it to save that value and use it later. Another important thing to know about return, other than that it just returns a value and you can store it and reuse it later, is that if, for example, I wanted to print out something right after the return, and let's say I do want to print out this, did this print, we're going to do A plus B so that we can actually see the results here. When we run this, we should get an error just even on this, or we shouldn't get an error. What will happen is that we won't actually see it, because what the return does on top of returning that value is it also terminates your function. So the return returns a value and terminates your function call or your function. So anything after the return statement will not get executed. And you'll see here, code is structurally unreachable. That's because it's underneath the return. If I wanted to print this out, I would have to put this before the return statement and not after. See, and now it prints out, did this print. So this is the structure of task 6, is we get to see that it does print out here. It doesn't print, does not save your values, and it doesn't store it for later, but return can store your value and allow you to reuse this over again. So I can call this function again and get results for another function or another value here as well. So that's what task 6 was about, and we're going to move on to task 7. Now, for task 7, what we're actually going to be looking at for this is going to be section 6.8 in your books. And this is just looking at functions as objects here. So what I first want you to do is try defining say hello and printing out a greeting, and try coding this beforehand before you actually see the code, and I will explain the rest as I go through. All right, so firstly, what we're actually going to be looking at is we've been calling functions so far. We've been calling it here when we call correct add or correct in add or incorrect underscore add. And what this is in Python, functions are actually considered objects. Okay, and that just means that a function isn't just a command. It's not just a call. It's not just a function. It's a thing that actually Python can store in memory, pass around. For example, we pass in correct add function as a parameter into a print function. We can assign it a value or assign it to a variable, just like numbers and strings or lists. And what objects actually mean is that what I want you to think of it is that everything in objects, including numbers, strings, and lists, even functions, these actually live as objects in memory. So an object is going to be something that you can store in a variable, like name equals, and we have a string called Liddell. This is a name object here, or string object here. And then we could also pass it as an argument. So I can pass in a string argument into the greeting function like we did at the top, or I can return it from another function. So for example, I can return another item. So in this case, I returned numbers, which is a number object, to a variable here, function here, and it's stored in a variable. So in this case here, when we create a function that we call say hello, so we're going to define it, say underscore hello, we're actually creating a function object called say hello. And we're just going to print out hello. And then in this case, what's actually happening here is we're going to now store the say hello object into a function, another variable that's called, and we can name it anything we want. So in this case, when I test it out, let me testing, we will call this variable a function alias, and I'm just going to shorthand it doing func underscore alias. And what we're going to assign to it is this function object called hello here. Then what I'm going to do is call it through the new name. We're going to call that function through the new name called func alias, open close parentheses. I'll put it here, store, oops, function in another variable. And what we are seeing here is that we see that both say hello and func alias are the exact same thing. So they're both going to be pointing to the same function object in memory. So we see here func alias prints out hello. And if I were to call again, say hello, or if I were to call here, say hello, it would be the same thing. Let me save it, run it, and we see hello again. So both of them points to the same function object in memory. So you could kind of think of this, honestly, like saving a shortcut to like a document on your desktop, and you can double click either the original file or the shortcut, both to open the exact same thing. So so in this case, it's just going to be func alias is that shortcut, and say hello is the actual document. That's how you can kind of visually think of it. So I'm going to go ahead and actually comment this out. Comment this out, and I'm going to copy this. And actually, I'll keep that there because that's part of the alias. And we're actually going to call this so that we can just see both. And I'm just going to put here /n, calling both func alias and say hello. Same output and function object in memory. So it points to the same function object in memory. All right, so we're going to save this and run the say hello function at the very bottom. Oh, I forgot that's not actually in it, so I'm actually, oops, where's it at? I forgot. It did not include the other one. So we're actually going to call all of this, and we'll just comment it out here. But okay, so actually, instead of just calling say hello in main, I'm just going to assign say hello to the variable func alias, print it out, and then print out func alias and also say hello. So we're going to save that and then run it. And we should have the outcome here. Yeah, there we go. So we have both outcomes here. So now we have completed task number 7, where we're actually looking at functions as objects. So now the next thing we're actually going to be looking at is task 8, which is looking at 6.10 in your Xi books, which is just looking at the scope of functions and variables here. So in this case, what we're actually going to be looking at is we're going to create a global variable and assign x to 10, or assign 10 to x. And then we're going to define a function called variable scope example with a local variable and print both. So I'm going to ask you to pause and then watch the rest. So in this, we're just going to go ahead and we're going to talk about variable scope. So basically where your variables live and who can actually see them is what we're looking at. So in Python, a variable created outside of a function, like so, is going to be considered a global variable. And we talked about this in the past when I kind of was trying to introduce you to you when we got around to variables, so that you don't kind of see this a little bit later on. But at least you learned it together with variables. So what we're first going to do is define our function. What we're secondly going to do is define our function variable underscore scope underscore example. And we're going to have our open close parentheses. And I'm just going to have a pass here for right now, but we are going to have a local variable and we're going to print out both of them. So first things first, a variable created again outside of this function is a global variable. So that means that I first want to print out x equals 10. So here I'm just going to say global variable x equals 10, open and close curly braces, and we're going to just make this an f string. And inside of here, I'm just going to pass in x. And then I'm also going to do the same. So I'm going to just copy this and print this out here. And I'm going to say y equals 10. Or actually, I will make y equals 11. And we're going to get rid of the pass statement here. So we're going to save this, and then we're going to test this function out so we can see what it actually looks like real quick. So I'm going to copy this header, a line underneath, call it. And what I will do also is just print out down here. I'm going to do another print. And I'll line it down here. And I'm going to do global variable x, and we're going to assign that 10 and get rid of y down here. And I'm also going to get rid of where it says on where I have global variable y equals 11. I'm going to actually change global to local because that is considered local variable to the variable scope example. And we're going to then print that out. So I'm going to save this and run this. Okay, so we see here the global variable is x. It's a variable that is outside of the function. It's global. It belongs to the entire cell here, or the entire program. So we can see here that x equals 10. And we also see here the same thing, x equals 10, and I'm going to just do a star to this one so you can see the difference, and then a money sign here for the other one. We're going to save, run. And we see here, yes, the global variable here is 10. The value doesn't change. And then down here, the value is the same as well. We also see here that the local variable stays the same. We have where y is equal to 11. So in this case here, you understand the global variable exists outside of the function. Local variable exists inside of the function. It's inside of the classroom rules here. So you can think of this as like a school rule book versus a classroom rule book. Like global variable is a school in general, everyone has to follow it, versus a local variable is just in the specific classroom that you're in, only that applies to that specific classroom. But we can use an item inside of our function here to actually update our global variable. And this is the only way for us to be able to change x equals 10 here, the assignment of that, and it would be modified not only inside of this variable scope, but also outside as well. So in this case here, I'm just going to type in global keyword. And because I want to update x, I'm going to say global x. And what I will actually do inside of this function is I'm going to update x to be 200. So we're going to assign 200 to x inside of this function. So we're going to use global keyword is to update global variables. And so what we'll see actually, and I'm going to go ahead and use this print statement, is I'm going to print out x before I update it to 7. And I'm going to say the output should be 10 here. And then when it's printed out, so after updating 10, it should actually, the output for this one should be 200. And then y should stay the same. But we will also see here that this will be updated as well. So when I save it and I run it, we see here, yes, prior to us updating x to be 200 on this line, we print out what x was originally, and we know that x is 10. Then we print out the update after x has been assigned to 200, and it prints out x is 200. And then we see in the output or the print statement outside of this function, x is now 200. So again, you can declare a global variable outside of a function, but you can update that variable inside of the function by using the global keyword here. And this would just be like updating the school rules. So again, globals live outside of all functions. Local variables live inside of a function, and the global keyword actually is going to give full permission to you to edit the big or shared version. So I hope that makes sense. And what we're going to do is just give a call to main. And we will comment that out. And call it down in main. All right, just to make sure it works. Okay. So now the next thing that we're going to move on to, and this will be pretty much similar. The only difference is now you get to try it yourself. So in this case here, you're going to have a global variable, and it's going to be using the same variable name, so it's going to be using y. So I want you to try your hand at it, and then we will go over this part, and we'll go over a little bit another thing attached to it as well. All right, so now now that you know about like local and global variables, we're going to see how Python actually keeps track of where each names live. And this is what is called namespace for the terminology aspect of it. A namespace, you want to think of this as like a labeled box that kind of stores the variable names and their values. And I'll explain that in a little bit here, but each function is just going to get its own local box. And Python also has global box for variables defined outside of any function. So we're going to just write this example. We're going to define demonstrate scope, open close parentheses, and we're going to have two different variables, or the same variable here. So the first one we're going to call as y. We're going to name that y, and we're going to assign to it a string called global. And then inside of the function, we're going to have a variable called y, and we're going to assign to it local. And then what we're going to do is just type in what it's asking us to print out, and I will explain this in a moment. But we're just going to print out the local and global variables using globals, open, close parentheses, open, close square brackets, and passing in the value that we're looking for, which is y. So we're just going to print this out. And I will add something here to the front in a moment, but we're just going to do what we have so far and then work that way. So it says to do globals, close parentheses, open, close square brackets, and y here. All right. So in this section, how you want to think of this is that when we call this globals, open close parentheses, y, which is directly saying that we're reaching the global namespace box, it's actually pulling out those global value instead. And so you could think of it as having like two different whiteboards, one being inside of the classroom, which is this local variable here, which is local, not variable, local. And then in the school hallway, which is pretty much the global here, right? And so when you write on the classroom board, it doesn't change what the hallway board says. So having this local variable being y, I can print this out right now. And I will just say inside the function, here. And then I'm just going to put y here. And then here, inside of here, I'm in the next print statement where I have globals, open, close parentheses, square brackets. What I'm going to actually do now is just put global variable. All right. And in this, what we're actually going to see is that the namespace itself is not necessarily like any specific location. What namespace is it's just a collection or a container that maps the names to the object they refer to in memory. So think of it as like a system that keeps track of all the names, variables, functions, classes, etc., and what they point to. And so in this case here, when we're looking at the global namespace, we're looking at all of outside all functions, the entire file pretty much. So any variable that's outside of any functions, the entire file. When we're looking at the local namespace, we're actually looking inside the functions. And for example, y equals local, that would be the local variable. It's inside the function. Python looks there for it. So the namespace is not like the specific line of code, but what it is it's just this invisible dictionary, quote unquote, like behind the scenes in Python that is used to kind of store the name and value pair together. So when you write y equals global here, Python adds that name y to the global namespace here. And then when you write y equals local inside the function, Python adds a new y to the local namespace. They're not the same one. And so in this case, if I wanted to, when I run this, it's actually going to show the global name, the y aspect of it. And I could also do the same thing for locals. So I'm just going to go ahead and print out both so you can see. Just do this \n printing, and we'll do locals, and close parentheses. And do print. And I'm just going to do the same thing, but for globals. And I'm going to just make this in a little bit more so it's indented in. I'm just going to do globals and globals. All right. And I'm going to save this, and I'm going to get rid of the pass statement there. No longer need that. And I'm going to test this out. Going to do testing, and we're just going to run this because this function will kind of show us both the globals and the locals. So I'm going to save this and run this. All right, so we see here, look, we have the inside the function here, we have a local, which is the value being stored in y, and we have the global variable, which is global, which is the value being stored in global assigned to y here. And then we have here where we're printing out both locals, y and the local. So the key is the variable y and the value is the local value. And then we have globals here where we're seeing, okay, and in this case, we'll see the if or the main that we talked about earlier, the name. So we know that name is the key and main is the value. The doc and automatically create a module for it, and we have all of the global variables that are associated here that we can actually see. And this will show all of them. So that will be like built-in functions, all of that. Like, so we have different types of namespace. We have local, global, and built-in. So a namespace is just a contact list of those specific, of those specific types there. So that's what namespace is, and I hope that that makes sense. All you would need is these two lines here. This was just an example. All right, and well, first I want to recorrect my function name and spell it right and not have W there. And then what I will actually do is copy this, comment it out from testing since I know it works. And I'm just going to run it inside of this main class here. Okay, save it and then go up and we will move on to 6.7. So in this, we're actually going to be looking at functions with branches. So in the past, you guys have worked with if, elif, else statements, branching, and we use these for conditioning, but you can also interchangeably use these within functions as well. So we're going to go ahead and define a function called classify underscore number, and pass in some variable num. Apparently that's going to get assigned to the variable num. And we're going to use if-else statements to print if the number is positive, negative, or 0. So in this case here, if we know that we're going to get a value called number, what I'm going to do is first pass this, and I'm going to do testing of it. I'm going to call this function with an argument to assign it to that variable in the parameter of the function. So I'm going to pass in the literal value number. So I'm going to pass in, we want to check to first see if a number is positive. So I'm going to pass in 4. And I'm going to make sure that that just says it's a positive number. We're passing in 4. And then I'm going to call this function again, because this is just making sure we test all possible cases here that's asked of us. I'm going to do -4. This should be the negative number. And then lastly, I'm going to call this again, and I'm going to pass this in with 0. And this should just be 0. Okay. So in this case, we know when we test this out, if we do our branching right, then we should have a positive number display out, we should have negative number display out, and we should also have 0 display out. So first and foremost, we're going to get rid of the pass statement there. So the first one's going to be 4. So if we're trying to check the condition and make sure it's a positive number, we know that any number more than 0 is going to be a positive number, positive integer there. So we're just going to say if that number, the variable we're passing in there, if whatever value, and in this case 4, is greater than 0, then of course we're just going to print out positive number. And for the elif portion, we're going to say, okay, if that number is less than 0, because anything less than 0 is going to be negative in this case, we're just going to print out negative number. And then lastly here, because we've checked for anything greater than 0, we've checked for anything less than 0, the very last statement we could check, it would actually be 0. So we know that anything other than that, it's going to be 0, and we're just going to print out 0. Okay, so that means each condition, when we run it, we should be able to see some good input here. So I'm going to just do what we had before and make sure that I have this statement properly written. So it's the same each way. Oops. 0. All right. Now we're going to save it and run it to test it. All right. So we do have where it is positive, negative, and 0, and it works for all 3 conditions. So we're going to go ahead and copy that, comment it out here. These testings are always used to go back to see if there was something that you made a mistake at, even though you're putting it in main as the final run. I'm going to say okay, and we're going to make sure this is indented correctly. All right. Save this and run to make sure it works as a full program. Ooh, Dennett shit is not defined. Okay, so demonstrate scope. Have to probably run it first. Okay, save And then run this. All right, and so we see that it works. Everything works well. All right, so we can move on to the next task here, which is going to be task 11. So in this here, we're going to look at two different types of parameter arguments here. We're going to look at quarks and args here. So I want you guys to try your hand at defining a function. Try your hand at this process before we move on to the next, and I will actually show you the right way to do it. All right. So sometimes we actually write functions, but we don't necessarily know how many items or pieces of information we might need. So that's where we use, I'm going to just make a comment here so you can see it. We would use args and also quarks. And both of these, they will make your function flexible as well as future proof. So we're looking at flexibility and reusability here. So in this case here, when we look at, let's start with first looking at like a default argument, an argument that we can actually have a default value to. So in this case, we're just going to firstly define a function called send underscore message, and we're going to pass in two parameters. The first one we're going to pass in is the variable recipient, and then the second one we're going to pass in our default value here, and we're going to assign to the variable sender admin. Oops. Okay. And then what it's asking us to do is print out a message showing the sender and recipient and call it with or without optional arguments. So first thing I'm going to do is just print out this statement here, and I'm going to use string, and I'm going to just say from, I'm going to do \n. We're going to say from, and we're going to have open close curly braces here. And we're going to have sender, and then we're going to have /n, and here we're just going to put a message saying it is with great privilege, pleasure actually, to offer you this position. Actually, we'll probably just put 2 here rather, and we'll put in here recipient. And then here on this part of the line, we're going to put \n, and then put 2 of these little carets, and then just say from, and we're going to just put inside of here sender. So we should have some statement here now that we have this function. I'm going to just go ahead and create a few new lines here, but it should be printf /n 2 carets to recipient comma /n. It is with great pleasure to offer you this position, and then we'll say from the sender. So we know that that's what's going to get called here. So in this first function call here, when we test it, we're going to call this with some recipient, and I'm going to just put a string in here. And then we're going to call this function again. And we're going to pass in Bob, and then we're going to pass in Dean. And then we're going to call this function again, and we're just going to pass in another one, and we're just going to change from Dean to secretary. And we're going to change Bob to be Helen. All right, so we're going to call this function 3 times. We have one that just passes in one parameter, one that passes into a different value for the second, and then one that passes into another value for the second. And we want to kind of see what actually happens with this. Okay, so now I'm going to run this real quick after I save it. So we see here the first one, it says, to Robin, it is with great pleasure to offer you this position from admin. Then we say to Bob, it was great pleasure to offer you this position from dean. And to Helen, it is with great pleasure to offer you this position from secretary. So what this actually means is here, sender, it is the default value, or the default value for this is going to be admin. That means if we only provide the recipient here, like Robin, for example, Python will automatically fill in that gap, and so we have admin here anyways. Think of it like an email form that says from system. Unless you choose another name, that is what will get stored into sender here. And like we did with dean and secretary, we chose that so it updated that value to now be whatever value we wanted. So now, though, what if you want to accept any number of values, not just 2? That's where args come in. So apart from the default value here that we have, we want to also look at args. And so in this case, I'm going to do this example below, and then I'll also show you the quarks example, which is what should be here. So the first thing we're going to do with this is actually, we want to accept any number of temperatures here, any number. So instead of us having default value, we want to just accept anything. So first things first, we're going to define average underscore temperature. And with args, what you'll usually see, by default, we have the value args. And this is just by convention. You don't necessarily need to have it named args. It can be literally whatever name you want. So just be reminded of that. Okay, so in this case here, I'm just going to change args to be temps to go along with the instructions. But again, it can just be args alone here, just as long as it has that asterisk. Then the next part of this is we're going to actually return the average of any number of lengths here. So in this case here, when we're actually trying to do the temp, we're going to be taking in multiple temperature values here. So we're going to just use our return keyword here, and we could store this in a variable. And in fact, I'll do it in this way so you can see the 2 different ways. So first thing first, we can actually have the sum. So I'm going to put total equals, and I'm going to use the built-in function sum. And inside of this parameter here, what I'm actually going to put is the variable's temp. So I'm going to say I want the sum of the values being passed into this function here. But then on top of that, what I want is to actually get the average of it. So in that case, I do need to also get the length. So in doing that, I need to call the length function and pass in temps again, so it can get the length of however many arguments we are passing in here. And then afterwards, what I want to do is create a variable called average, and I can actually just do total divided by length. And in this case here, what it's actually going to do is assign it to average, and we could either return average, and that will be the end of this function, or, for example, I'm just going to print this out for a second, or we can actually just do it all on one line instead of separating it into 3 lines like we've done. We could have sum temps divided by length temps, and this would do the exact same as these 3 items here. So let me go ahead and just, you'd have to put return average if you're wanting to use it here. Let me just go ahead and copy this, paste, and I'm going to comment this out because we don't need it. And so they do the same thing. This could just be one line of code. So now the next thing that I'm going to do really quickly is to test it out. How do you test out multiple inputs from the parameter? How do you do that? So in this case, if I want to have multiple numbers of values, not just 2 being passed in, I'm going to call this with multiple temps here. So I'm going to get rid of, finish testing, and then get rid of this here. And inside of here is where I'm going to put in all those different temperature values. So with this, I can type in different temperatures. So we have 90, 85, or I can call this function again with more values. So we can do 60, 63, 65, 70, 72. I can also create a list here, and I can just do temp underscore list here and assign it to a few things. So 72, 74, 70, 69, and then I can call average temp here. But when we call it, because we're using a list here, the syntax that we're going to use to kind of unpack that list here so that it can actually pretty much be displayed out, or Python will treat them as individual objects as opposed to just 72, 74, 70, 69, is just by having the asterisk in front of the name. We're going to do temp underscore list, and we'll be able to see that. And this will be as if you typed in 72, 74, 70, and 69. All right, and so what I'm going to do now is run this. But what I want to explain to you in this, when we run this, did it say that? Oh, forgot. It does the last thing, so I need to print them out each time. So you can, okay, so we're going to do this here, and then print this out here. All right, so we see that we do get the average printout of 90 and 85 as a temperature. We take in 2, and then we get the average of these 5 items that we pass in. And then we get our list, and we get the average of each of these. What I want to show you first is, like, let's say we print out temp underscore list, and then we print out asterisk temp underscore list. It should display the unpacking of it. So we see here, this is what I wanted to show you. This is what is called unpacking. So in the original state, it has it in the list form because that's how we stored the value in our list object here. But then when we use that asterisk in front of it, we're identifying or saying that each of these individual items are being passed in. So you'll notice that there's no comma there, and it will give us that average here. So what this, inside of this function, what this asterisk temps is actually doing is just collects all of those positional arguments. It's called a positional argument. And the values are pretty much separated by commas, and they're actually stored inside as a tuple. So you'll be able to see it as a tuple. So the args is a tuple. You'll notice the parentheses when you print them out. And tuples are ordered, which means the position of each item matters. So for example, if, for example, you wanted to pass in like 72, 70, 65 in that order, you would have to first put in 72, 65, and 70 in that order. Whatever order you pass it in is whatever order it goes in. So this would be, let me just put a comment at the top. Do args. Is considered, and I'm going to type in that word as well so that you understand positional arguments. Values are separated by commas. And stored inside a tuple. We'll just also say order matters. Okay. So you can think of this as just like a box of number slots, but order matters with that. The next thing we're actually going to look through, as hopefully you understand what args is, in terms of just being able to have one asterisk in the function parameter here. This takes in multiple values in positional arguments, meaning the order matters, and it gets stored in as a tuple. So if, for example, I print out temps here, we'll see, oops, control save, run. We see that temps get stored as a tuple. So we have a tuple of 5 items, a tuple of 2 items. So think of args, positional argument, tuple, order matters. We'll go up now to quarks to add in more functionality. So in this case here, if I wanted to, for example, use quarks with this, think about what you think I would actually pass in versus not pass in. If I wanted to use quarks here, it's similar process with the asterisk, but it's a little different, sorry. Now for this, if I wanted to modify this, and I'm just going to leave this as, I'm going to make a comment and say this is our default argument 1. Right above that, though, we're going to use and define another one. So I'm going to do def, and we're going to do send message quarks at the end here. And I'm going to go ahead and add in the recipient. We're going to have the same thing so you can see how to modify it. We're going to have sender equals admin. And then as the third parameter here, what we're actually going to do is use asterisk, then quarks here. And this allows us to, since quarks is in this function, it acts kind of like a number of named arguments. So it can handle many more arguments as opposed to it just only handling 2 here. And I'll be able to show you that with this one. Okay, and so inside of this function, what I'm just going to do is copy this same line and paste it inside of this function. And then I'm also going to include in here a few other items. So first thing, I'm going to have that. We'll have quote, concatenation there. Do another F there. And from here, we'll do another concatenation and just do F string with this. And in this one, let's say I want to not only just include like the recipient, let's say I also want to include, the age. So I'm going to do \n, this, and I'm going to say, actually not age, we'll put your contract is, and we'll put, this will be where we put the year as a certain year contract. And then we will also have here for the location, control plus symbol F, we'll have location here, / location, and we'll put in here whatever location gets passed. And for right now, I'm just going to put this in here for right now, but it will be modified. And I'm just going to put in here years here. And right now, it's going to be modified in a bit too. So we know that we want to pass in location. We know that we want to pass in years. We also know we want to pass in the role. So we'll just put in position here. So we have 3 different items that we are going to be using here. Now let's see how to modify it. So now what we actually need to do, since we have added in a few print statements, we're actually going to go on to this line here and add in a few things. So I'm just going to put an added message and then another kind of a message here so you can see the difference. So in this case, we know that in this, whenever we're dealing with quargs or whatever quargs is, essentially what it is it's a way for us to have keyword arguments, right? So in short, what that actually means is that by default, the values make some parameter optional. So it just means that quargs, this asterisk quargs, is just collecting extra keyword arguments into a dictionary. And this does use dictionary as opposed to Args, which uses it uses tuples. So in this case, how this gets stored is it actually just says, okay, we can look through cards and selectively pull details, just the same logic as the others. The only difference is we're going to have a key value paired associated with that. So in this case here, it allows for us to have a little bit of flexibility, allow for us to have different parameters that we have to put in, regular parameters versus keyword arguments. And we're going to be using some built-in dictionary functions as well to be able to process all of this. So in this example here, we're just going to assign position, the value, and we're going to actually use quargs here. And in this case, just to keep it convention to show you that we could use it as well, we're just going to do quargs.get. So if you know that get function is a part of the dictionary, where in the first parameter we're passing in a single thing. We're going to pass in this case, position. And this is just going to be if the key is available, then it's going to make that position be whatever value we assign here. Um, uh, uh, Otherwise, it's going to be whatever gets passed in if it's not there. So in this case here, I'm just going to put as a second parameter if position isn't there. We're just going to assign like, temp contract only as the position. And then we're going to do the same thing for the variable years. So here we say the contract is this amount of years here. So it's we're going to use quarks dot get, and we're going to pass in as the first one, knowing the keys or the value here is years, and then we're going to assign to this 0, just to say if it is a temporary contract, it's probably be less than a year. And then also we're going to have the variable location assigned, and we're going to use our quarks variable name here to get access to, here we're going to have the location. And in this case here, I'm going to make sure that this is remote. So this will be the default, this will be the default, this will be the default if nothing is passed in to this quarks. And again, this could be named anything. I could call this personal data and just change this to be, could try this personal data and just change this to be personal data. Either way, it does the same thing. So I'm going to go ahead and do that just so you can see. I'm going to copy this and plop this here. All right, and so in this case here, the difference we will see is when we call this function, no matter how many parameters we pass in, at least for the third one, we will either have assigned to a default value and when we call it, or it will assign either temp contract only 0 or remote if nothing is passed in. And then we will compare the difference there. So we first had our default argument, and I'm now going to call over here. We're going to do our testing here. So this one, we're going to call it, I think, 2 more times here so we can see it. So in the very first one here, I'm just going to call this with my name as the recipient here. We're just going to do Bella here, and then in the second one, we'll do Ben, and then in the third one, we'll do Nico here. And in this case, let's just say the sender is the chair for the first one, the dean for the second, and let's say the president for the third, just to give it some versatility. And then let's say for the very first person, we do pass in some position. And we can pass in, let's say, a research scientist or something, and then we can pass in, what's the other one we have? We have the year of contract, so we'll put years here equaling 4. And then we'll have also the location, and we can assign to it some, let's see, some random place. I know we already got Muncie somewhere, so I'm just going to put like around Michigan here. And then in this next one, we're going to put in just the position, and we can type in software engineer, and then we'll type in years, and we'll assign to that like 5 year, and then we'll assign to the location. We won't assign the location there. In fact, actually, yeah, we won't assign a location there. I'm going to put no location passed in. And then lastly, what we're going to do is we're just going to sign, we're not going to pass in position, and we're not going to, we're going to pass in years. And so we'll just say years equals, and we'll pass in like 2. But we'll leave location and position not assigned. So here in this case, we have called the same function 3 different times. One passing in everything, one only passing in the position and the year, not the location, one only passing in the year and not the position. So we're going to go ahead and save this and actually see what the outcome is. Before we do, I'm going to go ahead and comment out the default argument stuff, and then we'll run this to test it. All right, so first things first, it said to Delhi, it's with great pleasure to offer you this research scientist, I guess it should be position. Probably should plop that in there to make it proper. Here. Yeah. Your contract is 4 years, location, Michigan, from chair. The next one, it says, to Ben, it is with great pleasure to offer you this software engineering position. And we passed in 5 years, but we didn't pass in any location, and it gave us remote. So we'll see that there. And then the next thing here, we know that we did not pass in a position and we didn't pass in a location. So what we should see here is, to Nico, it is a great pleasure to offer you this temp contract only position. Your contract is a 2-year position, so we pass in 2 and it's remote. So you see how this can work with different parameter values. It slightly depends on what you pass in and what you assign to it, but it does use dictionary key value pairs. So with Args, we're gonna Args here, we have 2 asterisks. We have naming convention can be different than Quargs. And we also have it stores as key value pair, which is more so dictionary based. And so we see that information here. So this is what was required, at least for your understanding. You didn't necessarily need to create this function per se, but you could just add in Quargs into this function and reuse in that way. I just wanted to show you the 2 different ways. So we have Quargs, again, using 2 asterisks. Naming convention can be different. It stores as key value pairs, so dictionary, and it's based off of the default value that gets passed in, or if none was passed in, it will assign to it the default value stored from the key value pair. For Args, we know that it uses 1 asterisk. It is positional arguments, so it's not key fault value or default argument values. It's positional. The values are separated and they're stored kind of in tuples, so order does matter. So both of them offer a bit of flexibility in the values that you pass into your function. So that's what is for task 12 and also 11. We're going to move on to the next task, which is going to be task 13, and this has multiple function outputs here. So in this case here, we're just going to define this function here, and we're going to define it as sum underscore and underscore average, and we're going to pass in the variable values. Then what it wants us to do is actually return both the total and average as a tuple, and we're going to print that in main. So if, for example, you don't kind of already know all of the details of this, what you can already do is just what you know. You know that you're going to define this function, so you can define it passing in the variable. We can use pass to go ahead and set that up. We know that we're going to have to do some form of testing here. And so when we call it to test it to make sure that it works, we have to assign some sort of value here. So we're going to pass in this case, some values. So for right now, I'm going to just go ahead and put in like 6 here for the time being until we finish up with this function here and as I explain it. All right, so the next step of this is for us to define a tuple. So if you wanted to, you could actually use args for this in the parameter, or you can create a list. It's completely up to you. So in this case, I'm just going to do num list, and I'm going to assign to it a list of values real quick before we get started. We're going to do 6, 7, 8, 9, and 10. And then we're going to just pass in num list here. And again, I'll show it to you with args. But the first thing we're going to look at is tuples. And so if, for example, you don't quite remember everything to do with tuples, you'll remember, or at least think about it and know that, or look it up with tuples. You can kind of think about what I expressed earlier on in the semester where tuples could kind of be coordinates. So you could think of it with that open close parentheses. So you have 67.99, comma, 76.88. And so in that case, you can see that tuples will have that open close parentheses. So what it says is we have to return both total and average as a tuple. So what does that look like? It means that it probably needs to have the return keyword instead of pass. And it needs to be in an open close parentheses here. And inside of it, we know that we're going to pass it, we're going to return total and average. So we have to have a variable called total and a variable called average. So now we kind of are using our deductive reasoning here. What we want to do is assign to total whatever gets passed in as value. So we know here that the value could be a list, it could be an argument, a plethora of values if we wanted to change this to args. So what we'll do is just use the built-in sum function, pass in the variable values. And then what we'll do here for the average is we'll take in the total and divide it by the length of the values like we did above. And then that will get returned to whatever we call it here. But if we're returning a value, like I mentioned up at the very top, I believe it was for task 4, maybe. No, actually task 6 here, where we returned A and B, and we could see the difference between a return statement and a print statement. In that way, we know that a return statement is going to return some value. So that means that we need to store it in a variable. So we could either print it out, just like that, or, let's copy this. We will have results, which will return that tuple, and we could actually print out results. So, and it will do the same. So we see that it prints it out as a tuple and it stores it as a tuple. And that's because we are sending it as a tuple. Now this allows for multiple output, so multiple function output. We could also store this into, if we really wanted to, and print it each item one at a time. So we could do print 0, because remember, we can access a tuple by accessing it by the index. And we can do 1 to print them out individually or modify it if we wanted to, or it would just print again as a tuple here. So let's go ahead and see that. So we see that it prints out results both as tuple, and then it prints it out as individual when we use it to access. Okay, so this is what this was asking us to do. We don't necessarily have to access it. We just need to print out the result. So either of those should work. All right. So we're going to move on to task 14 here, which is going to be 6.16 in your code. And what you're actually going to do is you're going to define this document demo, and I'll show you how you can actually use this built-in help function to view a docstring from another function in this. And it's good. It helps you to actually build your code with some built-in documentation of your own. So in this case, I'm just going to create a function called def, and I'm going to do documentation underscore demo. And then inside of here, I'm just going to put pass. And then I'm going to do another one. I'm going to do def, and I'm going to just do test help here, open close parentheses, and then pass. So now that you guys kind of have an idea of what pass is, we can now start using that while we're building the code. So the next thing of this is to actually use docstrings. All right, so what we're actually going to be using here, I'm going to get rid of this pass, is a docstring. And this is pretty much just short for documentation string. It's a multi-line string written with triple quotes. So when we were learning about comments, like single comments, or even having just single lines, or even or having hashtag, having, when we learned about strings, we learned about the single line here. We also learned about double quotes here, and then we learned about triple quotes. So we know that we have single quotes and double quotes to be able to have comments or assigning a string here. Or I'm sorry, not comments. These are assigned to a string here. And we could also use triple quotes here to just be the multi-line string, which allows for us to be able to pretty much just have any quick notes that we would like in here. So in this case, inside of a document demo here, we're going to just put return returns a hello message, and just going to do return. Actually, let's just do message equals string hello, welcome to documentation underscore demo function. And we're just going to return a message here. All right. And so the next thing we're actually going to be looking at is that Python automatically stores it like this docstring in a hidden attribute that's called, oops, let me comment this out. Stores it in a hidden attribute that's called doc. So similarly to how I showed you where we assign a hidden one that's name, and we assign main or whatever module function we want to run inside of, or a function we want to run inside of that specific document. Same thing here. This is just a hidden attribute that stores the doc type in there. And so it makes your code a little bit easier. You get to self-document, and you can describe it for yourself. And you can actually use this help function to view the docstrings from another function. And this is pretty much great for writing educational code, any APIs, or larger projects like I mentioned in class. So in this case here, what we'll actually do inside of the test help function is we will call this help function here and pass in the documentation demo function as a parameter there. And then what we will do is just, oops, Control Z, is copy this function, and we're going to test this out. And in this, all we should see is pretty much just returns a hello message. So when we run it, we see it says help on function, document demo, and module main says returns a hello message. So it shows us that. So in this, it's reading the docstring from inside of the the test help function here. So I hope that makes sense to you. This is just how you could go about doing that. So now we're going to move on to task 15, which is just looking at 6.12 here. And we're just going to define a function here called multiply. And we're going to pass in a parameter a and b. And inside of this, we're just going to return a times b. And what it wants us to do is call this function here. It wants us to call this function with both positional and argument key and keyword arguments. I want you to try your hand at this with what we learned about quarks and args and see if you can try it, and then I will show you. So firstly in this, for the positional argument, let's go ahead and we're going to test. And we're first going to do positional argument. And if you remember when I was talking about this with args, it's just dependent on whatever you pass in first. So if we assign A to be 10 and then B to be 4, and then we decide, I mean, in this case, it won't matter because the multiplication either way would be fine, but we would do B, comma, A, and it will actually assign to it, the first value will be, A would be B would be 4, and then B would actually be 10. And that's just because it's based off of the position you pass it in. But if I were to call this with my keyword arguments here, so change this to multiply, and we pass in A equals 10, and then we first pass in comma B equals 4. Again, this shouldn't matter. So I'm going to actually just have a quick print statement here so you can see, and we'll just say A is equal to this, and we'll say B is equal to this. Okay, so we'll assign B here, and then we'll assign A here, and we'll actually be able to see each time which is which. And in this case, I'm just going to go ahead and put a new line here. We're going to save it. So when we run it the first time here, we see when we pass in B as the first parameter, it actually assigns the value that's stored in B. It passes it into A, and that assigns A to 4. Then we assign, or we pass in the value that's stored in A, which is 10. We're assigning that to B, and that assigns B to 10 the first time around. That is the positional argument here. I'm just going to put it here. Oops. Based on position. And then here we're going to actually have, next to this one, this is just going to be our keyword arguments. Kind of like default value is what we assign. So even though we are assigning A to 10 as a second parameter and B to 4 as a first, because it is keyword, we assigned A to A, it's going to assign A to A. Because we assign B to B, it's going to assign B to B. So we see B is 4 and A is 10, which is exactly what we want. So I hope that makes sense when we're talking about positional versus keyword arguments and how you can understand the difference here. And I mean, you can kind of relate this to being args and this to being quarks here. All right. Next thing we're going to be looking at is task 16, which focuses in on 6.17. Now, in this one, we're going to take everything that we've learned so far, and hopefully you'll be able to kind of code this on your own as we've gone through all the other functions. But essentially, this is the engineering example. You're going to define and analyze temperature. You're going to take in some data, and then you're going to print out the minimum, maximum, average value. If the average is greater than 90, you're going to show a warning. So you're either going to show that, there's something overheating or the temperature is safe. So I want you to take some time and try to do this yourself, and then we'll come back and do it here. All right, so in this alone, I know that I'm going to have to define a function that's called analyze underscore temperature, and we're going to be taking in some data value. I'm going to type in past here. I also know that I'm going to need to call this function when I test it. Again, only do what you can do. Don't get stumped and say I don't understand how to do something. Try to do what you can do. So in this first thing, we know we're going to call this function with some data. So since this is taking in temperatures, and we know that we need to find the minimum, the maximum, and the average, and we got to check if the average is 90, show the warning. So if we're taking in temperatures, we could allow our function to accept a plethora of arguments and just pass them in as a parameter, or we can store it in as a list. Now that you have two different ways of doing things, I would pick the one that is the hardest for you to do at the present and then move on to the next one so that at least you have practice with both. So in the first one here, I'm just going to create a list, and I'm going to just say we're going to have temp1 list. Again, you don't have to do this, and then we're going to just do 80, 90, 67, 55, and 99. And then I'm going to pass that in temp1 list there. And I'm going to create another list, temp2 list here, and I'm going to assign a bunch of 89, 90, 91, and 94. Oops. 94. And then later on, what I'm just going to do is I'm going to modify this to take in multiple data points. But for this one, we're just going to call it here with analyze temperatures from temp list 1 and temp list 2, just to check to see that we have different values that we're testing. So now that we kind of have our testing set up a bit, just to check to see, what we're now going to do is get into our function now. So we have to monitor a greenhouse or a lab sensor data. So that means that first things first, we are going to have a section here that checks the minimum value and the maximum value because it wants us to print it out. So we're going to have a function called minimum. We're going to use our min function. We're going to pass in data. We're going to have a maximum function, and we're going to use our max built-in function. We're going to pass in data here. And then what we're actually going to do is we're going to create a variable called average. Now, we've been calculating average a lot today, so we know we're going to use our sum function, pass in data, and then our length function, and pass in data. So this is going to be the average. So we have the minimum, maximum, and average already. So that first part is done. The next part is actually using our if statement. And it clearly says if the average is greater than 20, just show warning, otherwise print safe. So it says else print safe. So we can just already set it up. If we don't know how to do this in and of itself, we just have our if statement. If AVG is greater than 90, we will want to print out something. So we can place that in there, some warning, else we're going to print out safe. So we can print out a safe message, and I'm going to just put a little emoji thing here with the check mark. We'll just say temperature is safe. And then inside of here, we'll put another warning symbol. So I'm going to do the emoji thing, which is for me, Windows period, and we're just going to have like a warning sign here. And then we're just going to say here, warning, system override. Oh, oops, overheating is what we want to say because we're in a greenhouse. Okay. So already we have everything set up in the way we're checking if the average is greater than 90, we print some message. Otherwise, we're going to print safe. We've done the minimum, the maximum, and the average value, and we want to print that out now. So how we can go about doing that is right after average, we use our printf. So we have our f string here. And inside of this, we're just going to put lowest, open, close curly braces. And then the next thing I'm going to have here, I'm going to just put Fahrenheit. Then the next thing we'll have over here is just highest. Okay. And open, close curly braces there. And we're going to do Fahrenheit. And then we're going to have the average, open, close curly braces, and then just do Fahrenheit. Now for the average, because we're taking in multiple data points, let's just assume that we want to have it be 2 floating points. It doesn't specify, but since you know how to do 2 floating points, I would highly urge you to just go ahead and intuitively do that whenever you're working on assignments. So we have average here, colon, dot to F to make sure that we have our 2 floating points here for the Fahrenheit. Then inside of highest, we're just going to substitute and place in there the maximum variable. And then we're also going to do the same for the minimum. And there we have completed the first, or this function, the scenario, and what it's called for us. So we're going to test it out. So we see the first one, the temperature is safe. So it is greater than 90. The next one, the temperature is not, the next one, the temperature is not because it's over 90. So it's warning of that. Prior to that, it's safe because it's below 90. But let's say in this case, you actually want to take in the args statement instead. So what we're going to do is just pass in or make that an asterisk, save it. And now I can actually call this function. And I'm just going to pass inside of here some values. I'm going to do 70, 56, 88, 110. And we're going to save this. And for this, because now we've changed it, and okay, the first one works, but because we've changed the header here to accept args, what we have to do now is actually unpack this list in here so that it can actually run. So we'll put the asterisk as a parentheses inside of there, and now we should be able to run it and it should work fine. So those were the 2 different ways you can do that. You can choose, and I'm just going to copy this here and paste it here. And I'm just going to call this args. And we're going to use this as, copy this. Get rid of this. start using the right term. List object unpacking, and we're going to name this one Args 2 because that's going to go for that function so they don't mix up the two. And you'll be able to see. So we have this first part. Using Args. So this is using what we used to do where we passed in the list object into a function. We're passing or using a list object. So that would be using this one. So we're going to save that and run both to make sure they both work. All right, and we see they both do. So you can choose to do the optional args with the asterisks, and then you'll unpack your list, or you can just call a list with multiple items. Either or, both functions work the same. It's the only difference is this is args, and this is just taking in a regular list object variable or object list. Now, the very next thing and the very last thing that we're going to be going over here is recursion. So recursion is one of those concepts that can be hard for some and easy for others, but it's I like it. I think it's well structured and it makes things easier, but it can also cause an infinite loop if you're not doing it well. So you want to think of recursion as looking into a mirror facing each other. Each reflection is going to get smaller and smaller until it disappears. So what recursion is, and in this case, we're looking at a recursive function. Recursion is when a function is going to call itself to solve a smaller version of the same problem, and it's going to keep on doing this until it reaches a stopping point, which is called a base case. And we'll go through what that actually means in a moment. But when we think about this in terms of math, and we'll use a factorial example here. So factorial example. And what we'll use is the number 5. So 5 factorial is just 5 times 4 times 3 times 2 times 1, right? So whenever we do 5 times 4 times 3 times 2 times 1, that is going to give us the factorial of 5, which should be 120 as the value. And if we look at this from a mathematical standpoint, what it is we have some number. And so here in this case, we're going to have that number, and we're going to have that number times that number minus 1. And then here, it's going to continue doing that. It's going to continue going on. So then we'll have that number minus 2, that number minus 3, that number minus the other one. So in this case here, it's going to continue being that way. So how we can actually go about processing this, if we know that each time it's going to be minus 1, minus this, minus that. So in this case here, what we're going to do is we're going to first start with the defining the function, doing what we know how to do already. So we're going to define the function called recursion underscore example, and we're going to pass in there some variable, some value, but first we're going to have the parameter n because we don't know what value yet. Then I'm going to go ahead and type in pass. And I'm going to first do my function call to, again, start with what you know to do, and then continue on with that. So let's say I want to test this out. I'm going to test it out with the first value of 5, knowing that if I did it right, the output should result in 120. Now, when we're using the factorial, we look at the base case being 0 or 1. If n is equal to 0 or 1, the function should return immediately, because in this case, it's either going to be 1 or, in this case, n minus 1. So we know that in this case, the factorial of n is going to be n multiplied by the factorial of n minus 1. So if we break it down like this, and we look at this as a statement here, what we know is how it should look whenever we call it, and I'm going to go ahead and put it inside of here in the comments so you can see. We're going to do a docstring for that. So here we're going to have 5, and we're just going to say, let me put this in here first. So we pass in 5, and so we know the first time around it's going to be 5 times the recursive call, and inside of here it's just going to be n minus 1. So in this case, it's going to be 4. And then this is going to get called again. So in this case here, we have 5 times and when we call it, it should return that n times n minus 1. So it's going to be that recursive call again with n minus 1. And in this case, it's going to be the 4. And then we're going to be passing in 3 here. Okay, and then I'm going to do the same thing here. It's going to continue on. We have 5 times, and then we have 4 times that recursive call, with that being, plop that in there, another one. 1, 2, 2, and then 3. So with this now having our 4, and then we're going to have our 3, because what gets substituted here for 3? And then we're going to have 2 in here. Make that around, okay. And then the next thing we're going to have is the same process until we finally get everything back the way that we want. So we know that we're going to have that 4 times, and then we're going to have that 3 times, and then we're going to have that 2 times, and we're going to have that recursion call, and then this is going to be 1. And this is what we should have back, 2 times 1. And it should look like this. And then lastly, when we do this, what should return back is 120. This is essentially how the recursive call is done. We keep going backwards until we finally get the very end of it. And in fact, I believe that this is actually missing for 1. We need to go ahead and do this because I will show you here the base case will have to be either 1 or 0. So in this case here, instead of it being that recursive call, it's just going to be 1 because it's going to return either 1 or 0. 0, then that 2 times 1, then that 3, and then that 4. Okay, so this is essentially what it will look like. So each call waits for the next one to finish, and think of this as like stacking boxes and then unstacking them. So in this case here, what we need to do is, and I'm going to just plop this outside of the function so we can see it better. Plop it over here and here. And then I'm going to actually edit this function correctly. So this takes an n. So if we know that here we need to have a base case, something that will stop something that will actually stop the recursive call. Here we're going to have if n is equivalent to 0, and we're going to use our or keyword here, n is equivalent to 1. What we're going to do is return 1. Then what we're going to do is actually return, so it's going to be else n times the recursion call. So we're going to call this function here. And we're going to pass in here, instead of just hard coding in n, we're going to do n minus 1. So each time it calls itself, it's going to decrease that item by 1 until we finally get where it returns that value 1 there. So once it gets to n minus 1, we're going to get to here. So it's going to be 1 times 1, 1, 1 times 2, 2, and then continue on with times 3, times 4, times 5, and then we're going to get our 120. So the final result, what's going to happen is it's calling all these functions, it's storing it, and then by the time it ends to 1, once it ends to 1, it's going to go back now, okay, return 1. Return 2 times 1 here. So now it's going to be 3 times 2. Return return 6 here, 4 times 6 here. And then here it's going to be that constant return back of that 4 times 6 there. Or, yeah, 4 times 6 there. And then that value will return 120 as the total final value here. So we're going to go ahead and do that and make sure that it returns 120. So when we run it, we do see that it returns 120, and so we know that it works. But in order to just check to make sure, we also want to check other values. So we're going to go ahead and I'm going to copy this and call with the value of 3, which should display out 6. Then we're going to call with the value of 0, which should display 1, because that is going to return 1 there. So we're going to go ahead, save this. And I need to first print them out, so that's the last one. Let's get this close, print open, and then we're going to do print open. There we go. All right. And then we see that it does return 126 and 1. So when it passes in this 0, if n is equal to 0, we're just going to return 1, and so we get 1 there. And then we keep on going. So n is going to be 3. Is 3 equivalent to 0 or 1? No. So we're going to do 3 times the call to the function again. So it's minus 1, so it's going to be 2. Then it's going to say it's 2 equivalent to 0 or 2 equivalent to 1? No. So then it's going to go 2 times the recursive call minus 1, or it's going to be 1 here. Then it's going to say, is n equal to 1? Yes. So then it's going to return 1 to this statement, and it's going to be 2 times 1, and then it's going to return 2. So when it returns back to the other one, we have where it was 2, and then we also have 3. So 3 times 2 is 6, and so that value gets returned to this function call here. So there's going to be a lot of tracing through with recursion, and we'll get to recursion in a few weeks. I just wanted to introduce to you a recursive function that pretty much just breaks down a larger problem and breaks it into a smaller subsection of problems until this base condition is met. And this will always have, it has a recursive call and a base condition, or a base case in this case, which is a condition to stop your recursive call. I hope this helped you. Please let me know if you have any questions at all. But what you're going to do now is just, let me do this. We're going to comment out the test and just call this down below. We're going to run this. And okay, we see that it works. So this is all that the code with me for entailed. We went through quargs, args, we went through function return, parameter, arguments, recursive functions, default values, global, local variables, the difference between return and print, the difference in passing a list and using a for loop to iterate through it, using a stub function, so using pass to pass over something, using docstring and using the helper function to print that out, using some built-in mathematical functions, type built-in function, as well as just some simple greets. So, and also learning what hierarchical decomposition is, which is simply just taking our bigger functions or a bigger project and breaking it into smaller, more manageable functions. We have main being the main controller and everything else just being subtasks that we're reusing. So I hope that makes sense, and we're going to go ahead and move on to the next.